quick explanation for everyone who wasn't able to be there. Talking about energy. So energy is the ability to do work. I keep telling you in class that there's a relationship between energy and work, and this is it. So once again, energy is the ability to do work. In a few days, we'll be talking about the work energy theorem, where we're going to get more into this. For right now, we'll just leave the definition as is. Now, this topic of energy in physics, it's probably one of the most relevant topics to your lives. Probably be one of the topics that influences your future lives the most. Is where we get our sources of energy, how we use it. It's a big deal. So let's really quickly talk about what are some of the different types. Usually one of the first ones that comes up is electrical. Another one I hear often is nuclear. Solar or light energy is something that we hear about a lot. Thermal energy. A lot of times I'll hear like sound or wave. We'll do sound / wave energy. Now, these are all good answers. They're all things that come to mind. What we're going to focus on in this discussion and what we'll focus on for this unit is mechanical energy, the energy in physical objects. So if I take a mass and I'm moving it, I'm giving it a certain type of energy. If I take a mass and I lift it, giving it a certain type of energy. That has to do with mechanical energy. Now, like sound waves, thermal, these are also subtypes of mechanical energy. But we're going to stick to macro objects, large objects for this. Now, specifically, the two subtypes of mechanical energy that we're going to be talking about are kinetic and potential. Most of you have heard of kinetic energy or potential energy from your middle school teachers. Now, potential energy. A lot of you have been misled by some of your other teachers. Potential energy is not stored energy. That's what it's not. It's not stored energy. You can store energy as potential, but you can also store energy as kinetic. What potential energy is it's energy by position. So think about a physical object. If I take a physical object and I have it in its ground state, you might consider that sitting on the ground. So sitting on the ground at sea level on the earth. If potential energy is energy by position, that means that if I take it and I change its position, if I lift it above the ground, then I'm changing its potential energy. And the higher I lift that object, the more energy I give it. The lower I lift it, drop it. The closer I get it to the ground, the less potential energy it has. Now, once again, we could talk about this in terms of chemical energy as well, chemical potential energy. So remember, if we have an atom, we have a nucleus in the middle, and then we have energy levels. Like we have a 1s orbital, and then in the next, we have a 2s orbital. Let's say that this is a hydrogen atom with one single electron. That one single electron in its quote-unquote ground state, the lowest energy state, it will be in the 1s. Now, if this atom absorbs energy, that electron will move from the 1s to the 2s. So it will gain potential energy. Once again, that's energy by position. it is moving further from the nucleus. It's moving further from its ground state. We would call this an excited state, and then it moves back down. So not stored energy, energy by position. Now, as I stated, the higher an object is above the ground, the more potential energy it has. Also, the more mass an object has, the more potential energy it has. So our equation for potential energy is going to be mass times the acceleration due to gravity times height. Now remember, mass of an object is in kilograms. The acceleration due to gravity, that would be meters per second squared. And the height is always measured in meters. Distances in the metric system for physics, always measured in meters. So we have kilogram meters per second squared times meters. I don't know if you remember this, but a kilogram meter per second squared is also a Newton. So this would be Newton meters, and a Newton meter is a joule. We learned that when we talked about work. So the units for energy are joules. Also the units for work. Once again, work and energy are related to each other. So potential energy of an object is mass times the acceleration due to gravity times height. Now let's look at a problem. So I have a sledder, and the sledder has a mass of 50 kilograms. Now, a mass of 50 kilograms, that would be roughly 110 pounds. So they're standing on top of a 12-meter high hill. That's roughly a 4-story tall sledding hill. Pretty tall. I want to know how much potential energy do they have if they're at the top of the hill? And then how much would they have if they're standing halfway up the hill? So if we look at this, the mass is 50 kilograms. So the mass of the object, which would be the sledder, is 50 kilograms. The height is 12 meters. Now the acceleration due to gravity, we have been using 9.8 meters per second squared the entire year. To make this math easier, so I don't have to reach for my calculator, let's round it to 10 meters per second squared. So we won't get an exact answer, but it'll be close enough for us. And then what we're looking for is the potential energy at the top and the potential energy in the middle. So potential energy is equal to mass times gravity times height. In this case, that will be equal to 50 kilograms times the acceleration of gravity, we're rounding that to 10, times the height, which is 12. So 50 times 10, that's 500, times 12, that is 6,000 joules. So at the top, 6,000 joules. In the middle, it would be 3,000 joules, because I would have half of the height, which would be 6. So 50 times 10 is 500, times 6 is 3,000. Now in this equation, height and potential energy, they are directly proportional. So if I double the height, I double the energy. So if the height goes from 6 to 12, energy goes from 3,000 to 6,000. Now kinetic energy, that's energy due to motion. That word kinetic, we know that means moving. So by looking at this, I already know that if an object has more velocity, it's probably going to have more kinetic energy. So if I increase the velocity, I'm going to increase the kinetic energy. Now, just like potential energy, where mass was involved, mass is going to be involved in kinetic. So the larger the object, the more kinetic energy it has. The smaller the object, the less. Think about a car. So if I have a really big SUV, has a lot of mass, it won't get as good of gas mileage as a small compact car with less mass. Why? Because that big car is going to have more kinetic energy that energy has to come from somewhere, and it comes from the gasoline. All right? Now, also, the faster you go in a car, of course, this has limitations, which we'll talk about later, but if you go really fast somewhere, as opposed to, say, going 55 miles per hour, it's also going to require more gasoline. There's more energy involved. Now, the equation for kinetic energy is that kinetic energy is equal to 1/2 times the mass times the velocity squared for the object. Now, once again, remember units for mass are kilograms, for velocity it's meters per second, and for energy it will be joules. Now, you could do some dimensional analysis here, and if you square meters per second, that's meters squared per second squared. That would be the same as a kilogram meter per second squared times meters, or a Newton meter. Newton meter is a joule. Now, if I look at this equation, so if I double the mass, I double the kinetic energy. If I double the velocity, I don't double the kinetic energy, because the velocity is squared. So if I double velocity, if I put a 2 in here instead of a 1, it would be 2 squared, which means kinetic energy goes up by 4. If you triple velocity, kinetic energy goes up by 9. So let's look at a problem. So I have a car. That car has a mass of 1,200 kilograms. It's traveling down the highway with a speed of 15 meters per second. I want to know how much kinetic energy does it have? And then if I doubled the speed, how much kinetic energy would it have? So if we look at what we know the mass of the car is 1,200. For the first case, we know the velocity is 15 meters per second. And then I'm looking for the kinetic energy. Now, right now we have one equation for kinetic energy, and kinetic energy is 1/2 the mass times the velocity squared. So let's plug in our numbers. We have 1/2 times 1,200 times 15 squared. And if I put that in my calculator, that is going to be 135,000 joules. Now, if I double the velocity, that would go to 30 meters per second squared. And if you punch that in your calculator, what you're going to find is that you'll get 540,000 joules of energy. That's 4 times this amount. Because if you double the velocity, you quadruple the kinetic energy.